A megastructure is an enormous artificial construction built on a scale far beyond ordinary buildings or even cities or engineering projects. It can refer to real-world creations, ambitious architectural concepts, or over-the-edge creations of science fiction. On Earth, the term describes massive multi-purpose complexes or infrastructure projects that can house entire communities, combine homes, workplaces, transportation, and services into a single interconnected system, or stretch across vast distances. In science fiction and futurism, however, megastructures become truly colossal, ranging from planet-sized cities and ring-shaped habitats to artificial worlds and star-enclosing structures built by highly advanced civilizations. What connects all of these examples is their incredible scale. A megastructure is not simply a large building, but one that is so immense that it functions like its own world. Now let's explore the different well-known megastructures seen in sci-fi and see which one is most likely the one that would be built by humanity in the future in real life. Let's get to it. Let's begin with the space elevator. This is one of the oldest and most realistic megastructure concepts ever imagined. Instead of launching rockets into orbit, it uses a gigantic cable stretching from Earth's equator all the way into geostationary orbit, around 36,000 kilometers above the surface, with a massive counterweight extending even farther into space. The elevator would slowly climb this cable, carrying people, satellites, and cargo into orbit for a tiny fraction of the cost of rockets. Such a system would completely transform the space industry by making access to orbit as routine as taking a train across the country. The biggest obstacle is material science, of course. The cable must be incredibly light while also being stronger than any material currently available. Steel would snap under its own weight, and even today's strongest fibers like Kevlar are nowhere near sufficient. Scientists believe future materials like carbon nanotubes or graphene ribbons might eventually achieve the required strength, although manufacturing them in the necessary lengths remains far beyond current technology. The physics behind the idea are completely sound, and no new laws of science are required. It simply demands breakthroughs in material engineering, and among all space megastructures, the space elevator is considered one of the most realistic possibilities that humanity could build in the next few centuries. That is, if we get the necessary materials. Then an orbital ring is often viewed as the successor to the space elevator. Instead of depending on a single cable hanging from orbit, it uses a rapidly moving ring that circles the Earth in low orbit at speeds faster than orbital velocity. This moving ring would support enormous stations suspended beneath it through powerful magnetic fields, allowing shorter elevators to extend down to the planet's surface. Because the ring is actively supported by its own momentum rather than hanging under tension, it avoids many of the engineering problems faced by traditional space elevators. An orbital ring could transport millions of tons of cargo every year, support orbital cities, generate solar power, launch spacecraft into other planets, and even act as a global transportation network connecting continents within minutes. Building one would need or require millions of tons of steel, advanced superconductors, large-scale space manufacturing, and thousands of launches into orbit before construction would even begin. The energy investment would be enormous, but still well within the total energy output humanity could produce in the future. But most importantly, orbital rings obey known physics and do not require exotic matter or impossible materials. Now, ringworlds, and more specifically the Halo rings from Halo, are some of the most recognizable megastructures in science fiction. Each ring is roughly 10,000 kilometers across and rotates to create artificial gravity along its inner surface through centrifugal force. Entire ecosystems exist inside these colossal megastructures, complete with mountains, forests, rivers, oceans, weather systems, and countless species. Beneath the habitable surface lies an immense network of machinery, cities, factories, research facilities, and power systems. In the Halo universe, they also serve as the galaxy-destroying superweapons, built to destroy the Flood. Constructing even a single Halo ring, though, would require mining entire planets, moons, and asteroids of raw materials. The amount of metal alone would dwarf anything humanity has ever produced or could produce. It would also require autonomous construction fleets, artificial gravity generated through rotation, advanced life support systems, and engineering capabilities thousands of years beyond our own. The basic physics of rotating habitats is somehow realistic, but building one, or something this large, would require an industrial economy spanning the entire solar system. So no, this project would be beyond real-world physics and engineering of the foreseeable future. A topopolis, however, is essentially an endless long rotating tube habitat that can wrap around a star multiple times. Like ordinary space stations, which might house thousands or millions of people, a topopolis could stretch for hundreds of millions or even billions of kilometers, providing living space for populations greater than countless planets combined. As the enormous cylinder spins, centrifugal force creates Earth-like gravity along its inner walls, allowing cities, forests, entire worlds and entire civilizations to develop along an almost infinite landscape. Because the habitat can extend continuously, there is theoretically no upper limit to its size other than available building materials, and constructing one would require dismantling countless asteroids, moons and even planets to provide enough raw material for a small one around the sun. It would require an industrial economy capable of manufacturing continuously in space over centuries or millennia. The challenge is simply one of scale, and this is something that, without the existence of exotic or fictional materials and endless resources, would simply be impossible to build in the real world or the real universe. Then there is also the Dyson Sphere, which is perhaps the ultimate symbol of an advanced civilization. Rather than relying on planets for energy, a civilization could surround its entire star with millions or even billions of satellites, habitats, mirrors, solar collectors, and factories that would capture nearly all of the star's energy output. But contrary to popular fiction, scientists generally consider a solid shell impossible because it would be gravitationally unstable and would require absurd amounts of material. Instead, the more realistic version is a Dyson Swarm, where countless independent structures would orbit the star. Even this would be an engineering project unlike anything humanity has ever imagined. Building a complete Dyson Swarm would likely require dismantling Mercury, large portions of Venus, countless asteroids and even Mars, and even additional planets to obtain enough metals and construction materials. The total mass that would be involved would equal or exceed several planets. The reward, however, would be extraordinary. A civilization could harness almost all of its star's energy, providing enough power for trillions or even quadrillions of inhabitants. But the will, the resources, the energy needed to build such a swarm would be next to impossible, to be honest. Now coming back to Earth, an arcology is one of the few megastructures that could realistically be built by humanity in the relatively near future. Instead of cities spreading endlessly across the landscape, an urban sprawl, an arcology concentrates homes, offices, factories, schools, hospitals, parks, farms, transportation systems, and all of that inside one gigantic self-contained building. Millions of people could comfortably live and work within a single structure while minimizing transportation needs or pollution and land use. Everything from food production to waste recycling could occur inside the building itself, which makes it highly efficient and environmentally sustainable. Famous science fiction examples include the corporate arcologies of Neuromancer, the towering buildings of Judge Dredd, and the hive cities of Warhammer 40,000, which represents gigantic versions of the same basic idea. Unlike many other megastructures, arcologies require no exotic physics or impossible materials. Modern steel, reinforced concrete, advanced composites, nuclear power, renewable energy, and sophisticated engineering and governance are already sufficient for the first generation of such cities. The greatest challenge is not physics but economics, politics, and construction costs. Of all the science fiction megastructures, arcologies are amongst the most realistic and could begin appearing within the next century. Next to that is an ecumenopolis, which is a world where almost the entire planetary surface has become one continuous city. Instead of isolated nations spread by wilderness, forests, or oceans, nearly every habitable region is covered by interconnected urban development containing homes, industries, transportation systems, power plants, and all of that infrastructure. Such worlds could support populations reaching into the trillions while acting as the political, economic, and industrial heart of interstellar civilizations. Famous examples include Trantor from Foundation and Coruscant from Star Wars. A complete ecumenopolis covering every square kilometer of Earth would be extraordinarily difficult because humanity would still need enormous areas for agriculture, ecosystems, water management, and climate regulation. However, a partial ecumenopolis, like the Imperial Palace of Terra in Warhammer 40k, is somehow far more realistic as it is a continent-sized structure and not a planetary one. Combined with vertical farming, nuclear energy, advanced recycling, and highly efficient public systems, such a thing could be seen in the far future. I mean, we already have huge megalopolis like Tokyo and Shenzhen, and so if it spreads naturally, it would just become an ecumenopolis on its own. Unlike Dyson Spheres or ringworlds, this is primarily an engineering, environmental, and logistical challenge, which makes it one of the most plausible planetary megastructures humanity could eventually achieve. But at what cost? Anyway, we come now to the Death Star, which is one of the most famous fictional megastructures ever seen, and one that many might believe could one day be possible. This thing measures roughly 160 kilometers in diameter with enough internal space to function as an entire artificial world. However, building something of this scale would require mining countless asteroids or even moons and perhaps small planets rather than launching materials from Earth. The first challenge, of course, would be our current rocket technology or even mining with similar space engineering capabilities we have right now, or in the foreseeable future. Then there is the physics of energy consumption and time. Also, estimates suggest that constructing something like that would require more steel than humanity could realistically produce, which would take maybe centuries of mining under current global production. The economic cost also has been estimated to be at many thousands of times larger than today's global economy. And how do we even get them up in the first place and keep the entire thing from crashing back down to Earth due to gravity? Even if humanity could somehow possess the resources, the physics required would create an even greater problem. Unlike arcologies and partial ecumenopolis, or even orbital rings, which are consistent with known engineering and physics, despite their enormous difficulty, the Death Star, even though it is awesome, pushes well beyond what modern science considers practical. We might start with something like an orbital ring and then start to create mini Death Stars, but one of that scale might be too much for humanity to undertake. So looking at all these incredible concepts, some megastructures are surprisingly grounded in reality, while others remain far beyond anything our universe could realistically support. Arcologies, partial ecumenopolis, space elevators, and perhaps orbital rings are all physically possible with future advances in materials, energy production, and large-scale engineering, and the will to make them, which makes them one of the most likely structures or megastructures that humanity could produce or eventually build. Dyson Swarms, Topopolises, the Death Star, ringworlds, and Dyson Swarms would require civilizations with industries and economies millions of times larger than our own. Ironically, this means that the grim, dystopian hive cities of Warhammer 40k are actually far more realistic than many of the iconic megastructures of Star Wars, like the Death Star, primarily because a hive city is a terrestrial megastructure and not one in space. And so with that, we end this video. Do hit the like button for support and also click the bell button for regular updates on new video uploads. Subscribe to be a part of Legion Notebook, and till the next time, take care, boys.